Hello, this is Chris Hauser, and I'm doing the final project video for the EENG 3308 class. Um, so we're going to start by looking at the abstract. I decided to do this project solo. I ended up also deciding to do a two-wheeled line follower bot, very basic beginner sort of design. Um, I did a hardware implementation, although I did do some Tinkercad simulation to do some testing before building the bot. And while I did choose a white line follower bot, I ended up needing to go with a black line follower bot because electrical tape and poster board are the correct colors for a black line follower bot. In Tinkercad, I built a simplistic circuit that used an L293D motor controller, which was not the one I had available. And I used rheostats to simulate the effects of the photoresistors. So you can see in the simulation here that if the rheostat values are high enough, the respective motors are turned off based off of that. As for purchases, I purchased a multimeter, about the cheapest one I could find. I should have had one of these already. I purchased a set of different colors of wire, some lead-free solder, as I do not have access to good ventilation, some simple plug-and-play wires that allow you to plug into the pin controls onto the Arduino itself. I purchased a full resistor kit, as it could come in handy later, although I ended up only using two resistors at 22,000 ohms for this. I also purchased a soldering iron kit at 100 watts. I found this to be useful at a higher wattage than the 60 watt models, as I'm not very good with soldering. I also purchased a set of photoresistors. Amazon has been very helpful for all of these. And I purchased the recommended kit from the EENG 3308 syllabus, which was the VK Maker avoidance tracking motor smart robot. This came with an ultrasonic sensor and a servo attachment, although neither of these were used in the project. The kit itself was made from cheap Chinese mass manufactured goods. So it came with a few little caveats. For example, the power rocker switch that it came with was built backwards from the expected standards. So the off and on labels are not correct. Um, for the track itself, I put down two sets of electrical tape, so it has double thickness. This was to prevent false negative readings that allowed the bot to go off track, and I found the solution of using double thickness tape worked very well. Regarding the number of turns and the overall length of the track and various straightaways, I did this to demonstrate robustness in the design. In this picture, you can see where I chose to plug in the pins, along with my method of applying electrical tape to prevent the plugs from coming out of their holes, as the gauge on these wires was not quite correct for the Arduino. And once again, you can see the same thing here for pins 2 through, excuse me, 2 through 6, along with pins 9 and 10. Here is a picture of how the top side of how I mounted the photoresistors. The width of the spacing between the photoresistors was perfect for the hole sizes that were included in the board itself. Excuse me. Here's a bottom picture of the photoresistors, in which you can see my poor soldering, but this worked out pretty well for the design purposes. The kit came with a CD that was not utilized, although I went through more effort to get the contents off the CD than I would have liked, as CD drives are not readily available on very many computers these days. So I ended up not using anything from the CD, neither the instructions, the video, or any of the code. And I decided to build the bot with the motors on the top of the bot and the roller on a set of risers, which allowed the front of the bot to dip down far enough, as can be seen here, um, so that the photoresistor was about half a centimeter off the ground. This gave me more consistent readings using ambient light. I ended up using ambient light when, if I were to go back and start this project over, I probably would have chosen to use LEDs mounted to the bottom for more consistent readings. And here you can see the one reason I should never be allowed to be an electrical engineering major, in that I have some of the poorest soldering skills known to mankind. Finally, we have a working or video of the bot working. I ended up redoing and uploading the code some 30 or so times, as I had issues with speed, false positives, sometimes false negatives. Um, well, false negatives or false positives may seem like they shouldn't matter in this case. At the very end here, it does a little bit of a victory dance, and occasionally it would do the victory dance prematurely, which needed a little bit of adjustment to ensure that that didn't work, or that didn't happen rather. So our code base, we start off with some left motor control pins and right motor control pins being defined as LA, L1, L2, and the R's for, respectively. LA references the pulse width modulation, or LA and RA reference the pulse width modulation, which allows you to control speed. And then the L1 and L2, and respectively R1 and R2, need to be set to high and low individually in order for it to indicate forward or backwards motion. I also defined a sensory threshold integer or variable, which was calculated at being 430. The formula for this that I used was the photoresistor divided by the value of the sum of the photoresistor and resistor in the circuit. And I did some testing with a multimeter in the electrical tape to try to get values, and I ended up calculating out at about 430. But the through testing, 410 ended up giving me a better response. So for our void setup function, we set all of the pins to output pins, and then we disable the motors with all low states. When our loop runs, it does a function called direction check, delays the loop for 10 milliseconds, does a function called reverse stop, and then does another 10 millisecond delay. This was needed in order to regulate the speed of the bot. If I had it, if I went at full speed, it would often overshoot the lines, and if I ended up trying to slow it down with pulse width modulation underneath values of about 95, the motors would cease to function. So I found that it was the easiest to simply have the force apply into the opposite direction of what the bot expects, and this helped to regulate the speeds well enough that it was able to get accurate readings consistently without going too slowly. So for our direction check, it sets both the pulse width modulations to maximum 255, and then we take in a sensory input reading, which is attached to the voltage reading off of each photoresistor. Then it goes through a series of if-else statements, checking if the values of the sensors are either above or below the sensory threshold inputs, and then responds appropriately. In this block of code, the bot ends up turning to the right, as this pin is high and this one's high. So in this block of code, the bot will turn to the left. And in this block of code, if neither sensor is detecting electrical tape, the bot continues chugging along and going forward. And then we have a cute little bit of flair here, in which if both sensors have detected electrical tape, it believes that it is at the end of the course and does a little victory dance. I have some code here called full stop, which turns off the motors, and the momentum of the bot carried the motor, or allowed the bot to continue accelerating faster than I would have liked it to. So I ended up not using the full stop, and I utilized a reverse stop function in which I have the pulse width modulation and then set the motors into reverse momentarily, which did not actually reverse the bot. It simply slowed it down and regulated the speed. And the victory dance is very simple. First, it will turn to the left for 1 second at full speed, and then turn to the right for 1 second at full speed, and then the function calls itself once again, and it repeats ad infinitum. This again does not serve an actual function and is done for flair. So this is my Arduino bot, and I hope you guys have enjoyed it. Thank you.